What use is an F-call? In our hobby, we come across terms and names that we use and commonly understand. That is, we think we understand them. I mean, what's a velocity factor and what is a dielectric? Simple, right? The velocity factor is something to do with coax and the dielectric is something to do with capacitors. Next. Hold on. Let's have a little closer look at this. The velocity factor is the wave propagation speed, or the velocity of propagation relative to the speed of light. That is to say, it's a percentage of the speed of light. In a piece of RG58, the velocity factor is anywhere between 66 and 73% of the speed of light. You already know that the wavelength of a frequency is dependent on the medium it's travelling through. So when you calculate the wavelength of 21 MHz, you do some maths and out drops around 15 meters. If you want to make a resonant antenna, it has to be some part multiple of that wavelength. So a piece of wire 15 meters long will be a single wavelength. Well, no. The velocity of a wire will in effect slow down the radio wave. Thus it will mean that the resonant length is the velocity factor of the wire times the wavelength, or in our first example, 66% of 15 meters. Yes, I've not taken into account the end effects and all manner of other things, but it's a good first approximation. One thing to note, that a piece of wire with a low velocity factor can be shorter, thus likely take up less space and perhaps even be cheaper, since copper is not a cheap element. So if metal is metal and we ignore the hyperbole about a $200 HDMI cable, how does one piece of copper get a higher velocity factor than another? That's where the dielectric comes in. Another term for dielectric constant is the relative permittivity. It's the measure of resistance that is encountered when forming an electric field in a medium. We start with vacuum, which by definition has a permittivity of 1. Teflon has a permittivity of 2.1, polyethylene is 2.25, and for comparison, paper has a permittivity of 3.85, and water at room temperature is 80.1. Each of these materials resists the creation of an electric field in different ways. If you create coax with a dielectric that has a high relative permittivity, you end up with a low velocity factor, which means a shorter antenna or coax run. This is a simplified version of what's going on, since I've not talked about the thickness of the dielectric, the thickness of the copper, the spacing between the center core and the outer shield, but the basic takeaway is that everything is related to everything else. A simple term like velocity factor or dielectric hides a myriad of other concepts. Have a look around next time you think you know what something means. A surprise is sure to be waiting around the corner. I'm Onno, Victor Kilo 6 Foxtrot Lima Alpha Bravo.